Different languages handle mutability in different ways, and in this little short video I'm going to demonstrate how that occurs in a language called Typescript/JavaScript and a language called Rust. So let's jump into some code. So all the source code that's on here is going to be available in a GitHub project down below. It'll be in the link in the description. So let's write that code, and I'm going to be creating the directory. And you can see I've had to play around before. We're going to go into that mutation example, and we're going to create two extra directories, one for Node and one for Rust. Great, you can see that there. We've got our two directories, Node and Rust. Let's head into Node. And what we're going to do is we're going to initialize basically a kind of like what I call the Node repository. We use the -y flag because if we just did npm init, it asks you all these questions. So -y just makes it less interactive. And basically all we have here is a package file here. What we can do now is we can install Typescript, because essentially what Typescript does, it turns a Typescript into JavaScript for Node to run. And install that there. Let's go into our package.json. If I can type. Yeah, just need to delete that. You can see that here we've got our Typescript, which is a dependency. It could be a div dependency, but we can just leave it as a dependency for now. We're going to get rid of this line here. This is basically our scripts, which if we were to run the scripts, we'll do npm run test, for example, and it comes up with that error there. So we're going to get rid of that, and we're going to use the start keyword. And what we're going to be doing is we're going to be using Typescript. We're going to use Typescript to turn our future index.ts file into index.js and let Node run that. Great, so you see that there, we've got our Node modules, which has all our installation of Node in there, our package lock.json and our package JSON. And a lock just has the dependencies all pinned and a dependency tree. So let's create our index.ts. And you see I've got an ESLint error, but we can ignore that for now. So essentially what we're going to do is we're going to be demonstrating firstly, we'll just demonstrate why we need that Typescript dependency in there. So we want to develop in Typescript. Makes it a bit easier for us developers to have those type hinting and type annotations there. So here's an example of why we have to use that Typescript dependency. So if I were to create a variable like this, const number equals 10, which is a bit redundant because we're already assigning it to number 10, therefore the type of this has to be a number. But if we were to compile this or run this with Node, you're going to see that there we get this error here because Node doesn't understand what this colon here is, this declaration of the type. We have to actually use Typescript to be able to convert this into JavaScript for Node to be able to run. So see here, there's no index.js file, but if we run npm run start, you'll see it converts it to Typescript. Converts Typescript into JavaScript for Node to run, and you actually need to see a result. So if we do console.log 10, or actually num, and if I just do node index.js, we still get the same error. If I do npm run start, you get the number 10 printed off there. So that's kind of why we have this here, but that's not the whole point of the video. We want to talk about mutations and why that's important. So if I get rid of this here, when we declare variables, we have two sorts of keywords. We have const and let. So before it used to be var variable, but that's been phased out for those two particular keywords. So const, you can imagine, is just a constant variable. So for example, my name is going to be constant. We can declare the type here like this. We don't have to in this scenario because obviously we know that Shivan here is a string, and then therefore name will become a string. Now the issue we have here is with this constant variable, we can't reassign the name. So I can't do const name equals Bob. We'll get an error. We'll say that we can't redeclare the block scope variable. If I try and compile this, so npm run start, we get an error. Typescript gives us the error. And I don't know if Node will give you an error actually. X.js. Yeah, so it can't, not even JavaScript will run that. So this won't work, in other words. Even if we do this, get rid of the const, it won't be able to run. And if I do npm run, see, it won't be able to run. It will say there's an error there, you can't do that. However, if we declare it with let, So let means that we want the variable, we want to be able to reassign that variable. So in this situation, we can do that. So console.log name, put it up here. And yeah, we'll declare this as a string to as well. Because in this scenario here, it's actually thinking Shivan is what we call a literal. So literal is basically if we want to do Shivan Bob. So this type annotation here means that name can only be Shivan or Bob. It can't be, for example, we can't do Charlie, but that's kind of besides the point. So we'll call this a string. And I think this Typescript having some troubles. Yeah, we'll try and run it anyway. I think my the type checker here is not working properly. So let's do npm run start. And we've got some errors here. Okay, I don't know why name was stuck on being const, but what we'll do is I think name might be a special variable. So we do that there. Okay, so I do apologize. In this example here, because I've named it A, it's working. I think name must be a special variable, so I've just discovered that right now. But in this scenario here, let means we can reassign it. You'll see that later on, there's two particular data types in JavaScript that you can still mutate even though it's with the const, and I'll show you that shortly. So here is an example, if we did const here. Firstly, you can't just do const, and you need to assign it with a value. So you can't just have const A. It needs to be what's called initialized. So it has to have some sort of initialization, like Charlie. And you see that here, you can't actually reassign them like the example before. And if we try and compile it, it'll throw us some errors. So that's kind of the example of the difference between const and let. Now I want to show you what data types can still be mutated. So an example is an array. An array, you can imagine, if you're familiar with Python, is a list. So an array is basically something like this. So we've got numbers here, number of arrays. Basically a list of numbers there. We just do a const here. Now I should be able to print these out. So for, what is it, let A and R. I think it's ob actually. Console log A. If I did n, and if I run this here, you're gonna see numbers printed off there. So that's what an array is. An array is basically iterable. You can iterate through it like what we've done here with the for loop. We've iterated through it, printed off every single number. We can either do this if we wanted to. So +1. So essentially we're going to add 1 onto every element of that array, and we get 2, 3, 4, 5, 6, which is basically 1 plus 1, 2 plus 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5. Anyway, that's not the point. The point is I want to show you, finally, eventually, is that we think that constant means that this variable cannot change. It has to be the same. But I'm going to show you an example where it will change. So we can apply things like a push. And what a push does, just appends this element here, world, onto this array. If I get rid of this here, you're going to see that when I run the script here, you can see hello world. So we're allowed to actually mutate and change this variable even though it's given the name const. So you don't have to do let r, you can still do const. And let and const is mainly for, it doesn't indicate if a variable is going to be persisting being the same all the time. It just means you can't reassign that variable. So in this example here, yes, we can mutate the variable, we can change it, but we can't reassign r. So I can't do const, I can't go r hello world. It won't allow me to do that. Okay, maybe we can do that if I save it. You're gonna get that error there. But in this scenario here, we can mutate this variable. And the same goes with JavaScript objects. So here's an example of a JavaScript object. If we do something like this, a const ob, I'll call it o, const o, and we'll say it's hello. Actually, we want to do hello. And I can do o b equals world. And you can sort of guess what's going to happen here. Console console log this. And despite the fact, well, we can just be a bit more strict with the type hinting. So we go key, string, string. So this is basically a type annotation for this O. The key string means it's index, which is A. And in this case, it's B. We want it to be a string. So for example, if we did number, you're going to see that we're going to get an error there. You can't have that. It has to be this, for example. So that's what this type annotation is here. So if I do this here, you can see hello world. So even though it's const, this variable is still able to mutate, and the idea is you're not able to reassign. So I can't go O is equal to C, yes. Like I can't do that. That won't work. So I kind of really just want to drill that point down with you about mutations. Now, what's something that we could add to mean that we can't change this array? Well, we've got this type hint called read only. So if I do read only string there, now it's coming up with that error. And if we try and compile TypeScript, it'll give it, if we save it, if we try and run TypeScript, it'll give us an error that R must be a read only string, you can't redeclare it. So I hope that's interesting for you. Let's move on to another programming language called Rust, and we'll try and figure out why that's sort of working. So how Rust handles it. So let's exit out of this, and we'll go out of here, and let's go into Rust. Now, if I remember how to do this, so cargo new dot, or cargo init. Great, so if I go into here, and we'll go into the main, get rid of this. So essentially what I want to do is I want to create it's kind of like an array. So in Rust you have this thing called a vec, which is very similar to what an array is in JavaScript. There's actually arrays in Rust, but they're a bit more complicated than that. It's a bit more primitive than that. So let's create a vec, which we can basically mutate as well. Generally an array is fixed, if you're kind of familiar with C. So use let, and we'll use a macro here to create a vector. Or we could do something like this, like vec, there's a new, and let's just declare this is a vec, this is type stir, I'm going to borrow, so we've got errors here, we have a semicolon to finish it off, it's going to complain because we're not using R, and what we're going to do is we're just going to basically do a printing of R, so for A and R, let me get it this way. And we just do a print ln, and we're just going to print a. And quickly push stuff onto there. So we can do, let's just declare this with a hello, I think. So how do we do that? What was it from? Can't remember. U8. Let's just do a vec. This is the only way I'm familiar with how to do it. We can't just print it, we need to do this. Great, so the idea behind this is we should just print a hello. Let's see if we can push something onto here. Like world, well, get rid of this. And let's just run this. Cargo run. So it builds it, it prints off hello. Let's say we want to do hello world, so let's try and push something onto here. Just like what we did with our example with JavaScript. And you can see now we've got an error already. You can see that there. If I just do this, will it work? That R is not mutable. So in this example here, all variables, even though I've got this keyword let just means, let's just a variable declaration. You do have things like const, I believe, like hello, which are actually truly variables that you can't change. But in this example, all variables are not mutable. When I say mutable, it means you can't change them. So in this example here, we're basically trying to change this vector here, which is equivalent to an array in JavaScript and in TypeScript. And we're not able to do that. So it won't even let me compile the language. So if I do cargo run, it won't let me, whoops, if I save it, won't let me run this package because we've got this mutable variable here. But if I add mut here, you see that it allows me to do that. So you've got to declare this variable as mut. Now, why do we do this? Why do we want to have this kind of this sort of setup here? The reason is variables like arrays tend to get copied. Okay, it's really important you understand that they get copied. So if we go back to our example with the node example, so go here, and we'll go into our Typescript file here. This array here, if we get rid of this, and let's create like a function, for example, a function that does stuff to an array. We want an array, we want a string, and we want to do stuff to that string. So for example, we'll move this push over to here, and all we'll do is we'll just print off the const. So we've got the array here, and we want to create a new array, for example, a new array. And we're going to use this function here to add that world to that array. So we go does stuff onto the array, and we'll console log this. Now, the issue is with arrays can be considered to be quite expensive. They take a lot of memory up because obviously arrays, we can make it as big as we want it to be. So the problem with that is, as a computer, we don't know how big that array is going to be. So it could be a very expensive thing to copy that array. What most programming languages do, especially Python, they don't copy the list or they don't copy the array. They just copy a pointer to that array. So we'll create a new reference to that array that just points to it. So in this example here, even though we pass this array through here, we push world onto it, let's see what happens to the original array. So we're going to go here and console log the original array. So this is R, and this would be new R. And let's see what happens if I run this. And let's just return this actually. But you already still see the mistake here, because you expect this R, we expect it to be constant, we expect it to be just a hello. But in this scenario here, okay, okay, you get the point there. So what I've done here is, I thought I created a new array, right? There should be a new array right here. But what we've done actually is we've created a pointer to this array, we've performed a push on that array, and essentially we've just mutated this original data type, which is not what we expect. Because imagine we have another function that depends on this, and if that's changing all the time due to another function, they can cause problems in our program. So that's what Rust is there to prevent. So let's go to our Rust example. And let's say we create another function. This will take a vector, and we'll say this is R. And this will also take a vector which contains strings. And to this we want to apply a push as well. And I just figured out how to fix my mistake here. So if I go back to node, so you can see I'm pretty much doing this on the fly with errors. So for example here, we want to return R in this example here. Get rid of this. So I'll just run this real quickly. Again. You can see that there we get basically a carbon copy. So even though we've made a push to this world on this array, and remember here we create a new parameter, like if I do new, I could easily change this to R other, and it's the same thing. What we've done is we've made a push to this new array that we've declared, this new variable here, we're returning it and we're assigning it to this new array. That's what we expect. But then we've changed this variable here. That's been mutated by this function here, because essentially when we copy an array, we don't create a new array, we just create a reference to that previous array. So that's why that's changed there. And you can imagine that being, like I've said, coming back to the same point, it's really annoying because you can have another function that works on here. For example, we've got this function here that also takes an array, and returns it. And if we were to do const other array, now this is going to be affected by this function up here. It's not going to be the original value here. This is going to be doing something to that array, that R here. So if I do console log other R, you see here we're not going to get hello hi, we're going to get hello world hi. So do you see that there? That can be quite unexpected and a bit annoying to deal with. So if we apply the read only here, you're going to see that everything here errors, which is really good, and I won't be able to build that file. It won't let me run that. It won't let me build the Typescript. So let's run back to Rust. And I appreciate you sticking this far into the video. So even as an example here, we get errors here. We can't mutate this R function. We're not allowed to. So if I get rid of this here and I try and apply this, R equals you see, it won't let me do it. Oh, I need to return this type actually, so Vic. I'll do that. Cool. So essentially, I create this function here. It does the same thing, does the push, but it won't let me do it because we can't mutate the variable. And in fact, if we try and run this, type a run, it will say that there's an error there. We can't do that. But that's not kind of what we want, is it? So I want to return this. Sorry. So if I run this here, you'll see get the error. It's not mutable. R is not mutable unless we set this to be mutable. I think we do that by doing, is it mut here? Yeah. The example there does run. So in this scenario, this does get run. But we can see here this automatically gets borrowed. So we'll run into the same errors if I do this, do stuff again. And if I do this, see, I was going to complain about moving. So how Rust works is essentially what we've done here is this array here gets moved into this. Now this becomes the new owner of this. This basically gets dropped off from memory. So this is the new owner. And then in the scenario here, this is basically a dangling pointer. It doesn't point to anything. That's why it's complaining. So if I were to run this, we'll get an error. It's been moved. We can't do that. So what we'll need to do is we need to create a copy in the scenario, which I won't run through too much because I think it's a bit, yeah, I probably won't run through it too much because I think it's just a bit too much for this video so far. We're already 25 minutes into the video. But if we go back to the JavaScript version, see that here. If we go here, now in this example, we can get rid of the read-only. If we don't want all this happening, you know, basically different functions working on different things, we can basically add, I'll get rid of this just for simplicity's sake, because we know what's going on here. We can basically create a splice. So we go other, and let's just declare this as R, and we're going to create a const here, and we're going to copy that array. So the way we can do that is using slice. I think do slice 0, is it? I think, and basically what this does, this creates a copy of the array, so we get 2 separate arrays. So we're not going to get this copying again of what we had last time. And there you go, now we get the original array not being mutated by this function here. So I'm kind of hoping that makes sense. Excellent, thank you for sticking around to the end of this video. I hope it wasn't too boring, and I kind of did make some errors throughout the video, but I kind of want to share this kind of learning experience about mutability, which is really important, especially from learning a bit of Rust at work, and now I'm learning this kind of example here, and I thought it was a bit quirky with the const actually not being a constant. You can still mutate it. So I kind of hope this makes you a better programmer, because it's really important to understand what's actually going on. And this is quite a common mistake, is when you get data that's been mutated by another function, you don't know exactly what's going on when you look through the flow. So this is really important to understand where different things in memory get altered by different actors. And that's really important, which is controlled in Rust, but can happen in other programming languages. So I hope you find this interesting. If you have any questions or any feedback, please let me know. And yeah, my kind of goal is to make people who watch us better developers. I want to be a better developer myself. And this week has been a bit of a tough one, because yeah, I've just not felt like I've been productive or very strongly motivated to make these videos and do these sorts of things. So yeah, I really hope this helps someone out there. And as always, stay focused and talk soon.